Hi guys and girls, John here, and welcome to the first ever saVRee Snacks video. Today we're going to talk about a controlled pitch propeller, also known as a controllable pitch propeller, and I'm going to explain to you exactly how it works. This video is a special video because it's the first time ever that I'm going to try and get through the entire topic without doing any editing. And the idea is that I can produce a bit more content a lot more quickly. So, what have we got here? We've got a propeller. I'll do a little spin, and if we play the animation, you can see that the blades on the propeller are changing position. What we're actually doing here is changing the angle, and we refer to the angle as the pitch. The blades are rotating in their hub, and we're going to use this difference in angle in order to thrust the vessel either forwards, that is to say ahead, or astern. So by changing the angle on the blades, by changing the pitch, we can actually change the direction in which a ship would travel, or I'll say a vessel because it's a bit more generic. So how are we doing that? Let's take a cross section. You can see that there's quite a lot happening in here. This particular design of CPP, or controllable pitch propeller, is hydraulically actuated. We're going to use a hydraulic fluid, such as oil, in order to actuate the blades so that they rotate. There are two important things here that really explain how the whole thing works. One is this pipe here, the inner pipe, and the second is the outer pipe. We're controlling fluid flow in order to make the blades rotate. This piston at the end, some people might call it a servo motor, is going to move to the right or to the left depending upon where we send our hydraulic fluid, in this case hydraulic oil. So let's go down the center pipe a second. Maybe that's not a bad way to go. It's going to be a bit tricky. Okay, I'm in the center pipe. Let's go down here, and you can see we're just coming out at this section. So we came out here. So the fluid was flowing down this way and into this section. When that occurs, what we're actually going to do is push the piston to the left. Let's see if we can do that with the animation. There you go. So we've pumped fluid out through the center pipe, through this one here, and that's caused the piston to move to the left. The opposite of that would be to pump a fluid, hydraulic oil, into this section so that we can move the piston to the right. It's actually already moved to the right, and now it's moving even more to the right. But how did we do that? Well, we actually did it by pumping fluid through the outer pipe. You can see that we've got the inner pipe, which makes the piston or the servo cylinder move to the left. And then we've got the outside one here. And that's the one, if we pump fluid down there, we'll make our piston move to the right. We can do this because there's actually holes cut here. As you can see some holes where my mouse is, and there as well. You see the channel cut here. And out of these holes comes our hydraulic oil, our fluid. As we pump fluid into this space, it's going to push the piston to the right. And as a result, our propeller blades are going to rotate, which means the angle or the pitch of the blades is changing. Come back, you can see now we're putting fluid into this space on the right. It would be coming out through the center hole or the center pipe, and that's why it moved to the left. So by controlling the fluid flow and where it ends up, whether it be on the right side or the left side of our piston, we can cause the piston to move either to the right or the left in a linear fashion. What's weird though is the propeller blades themselves, they're not moving linearly. They're not moving linearly at all. They're actually moving in a rotary fashion. You see here, they're turning clockwise, clockwise again, and now anti-clockwise, and anti-clockwise again. So how are we achieving that? Let's take a cross section. Let me see if I can slow this down a second. You can see now the piston's traveling off to the right. And if you look here, this is the most important bit. This is where the propeller, the root of the propeller, attaches to our controllable pitch propeller mechanism. We actually call this the yoke. I'm going to hide it and show it. And if we invert the selection, you can see the yoke there. Invert it again. But the yoke is also traveling linearly. And if I change to this perspective, we can start to have a look at just how we change that linear motion to rotary motion. So the animation is playing again. You can see there, you can see it moving. As we get the linear motion here, we're getting rotary motion on our blades. If we go to the cross-sectional view, and if we go up here, you can see that what's actually happening is we're forcing rotation here by applying linear force. That's the reason why the connection here is circular in shape. Let me see if I can find a different one. You can see here the connection is circular in shape because it's going to need to rotate even though our motion originally was linear. You can see that here. And again. And coming back the other way. So in this way, just by using hydraulic oil, we can change the angle or the pitch of propeller blades and thus determine if the vessel is going to travel ahead or astern. This is just one type of design that you may have. It's quite a simple design in a way, although it is quite difficult to understand it when you're reading it in a book. I actually tried that the other day. Didn't work out very well, I'll be honest. However, when you do see it like this and you can take it apart, it helps a little bit more. If you've got any questions or comments concerning this 3D model, then by all means add them in the comments area. If you want to access this 3D model or learn a little bit more about engineering, then check out saVRee.com. Thank you very much for your time.